Question number 3 is a classic two-way table. It's going to be talking about a lot of conditional probabilities. So this would be a good way to review that. Let's read the question. A local company is interested in supporting environmentally friendly initiatives, such as carpooling among employees. The company surveyed all of the 200 employees at the downtown offices. Employees responded as to whether or not they own a car and to the location of the home where they live. The results are shown in the table below. So we have the table downtown area in the city, elsewhere in the city, and outside of the city. And we have car ownership. So we have a yes and we have a no, and we have all the individual numbers and the totals and the overall total. So this is the overall. So let's look at the question. Which of the following statements about a randomly chosen person from these 200 employees is true? So we want to choose one person and out of those 200. So let's look at the first one. If the person owns a car, he or she is more likely to live elsewhere in the city than to live in the downtown area of the city. All right, I want you to think about that, and I want to see if you can make those calculations yourself. So if the person owns a car, he or she is more likely to live elsewhere in the city than to live in the downtown area of the city. All right, you ready to figure out those probabilities? The probability of living, if the person owns a car, this is a conditional. So given car, given yes, what's the probability of elsewhere? So that one's going to be, what we want to do is we want to look at the overall yes. Since we're given that, we're only looking at those numbers here. And out of that 60, 15 of those are going to be elsewhere in the city. So given car, the probability of elsewhere in the city is going to be 15 out of that 60. Now let's look at the other one. The downtown area of the city, there are 10 of those. So again, if the person owns a car, so it's the same given, probability of downtown, and by the way, we used given with this little slash here. So downtown given, yes. Well, that's going to be 10 out of 60. So now we have those two fractions. We can see that the 15 out of 60 is larger. And the question says, if the person owns a car, he or she is more likely to live elsewhere in the city than to live in the downtown area of the city. And that's true. We know 15 out of 60 is larger than 10 out of 60. That's a true statement. So we lucked out. A is going to be your answer. But you need to go through the other answer choices so you know how to get all those probabilities, because A is not always going to be the one that's right. What if E was the one that's right? You had to go through all of those choices. So I'm going to go through and show you the other 4 choices and why they're wrong. So first of all, we've already concluded that A is correct. So you're going to see this work again. Now let's look at B. For B, it says if the person does not own a car, he or she is more likely to live outside the city than to live in the city, downtown or elsewhere. So let's see how that works. If the person does not own a car implies that we're going to use the no's. So given no, what's the probability that someone lives outside the city? Well, given no, 25 of those live outside the city, 25 out of 140. Now let's compare it to in the city, downtown, or elsewhere. So in the city, there are 2 locations in the city. Downtown is 60 and elsewhere is 55. So that numerator is actually going to be the sum of those because they're using both of those. And they add to 115. And as you can see, the question says, if the person does not own a car, he or she is more likely to live outside the city than to live in the city. Well, that's just flat out wrong, right? In the city is way more, 115 out of 140 and then 25 out of 140. So we know that B is not going to work, okay? And let's analyze the other ones. All right, let's look at C. See, the person is more likely to own a car if he or she lives in the city than if he or she lives outside the city. So in this case, your denominator is actually the totals down here. If a person is more likely to the person is more likely to own a car if he or she lives in the city. So let's look at the in the city. In the city is a combination of downtown and elsewhere. Those totals are 70 and 70. So that in the city, that overall totals would be 140, and that's going to be down here. Now, out of those 140, we see that 10 and 15 are the sum. Those are going to be 25, and those are how many people own a car that are in the city. That's 25 out of 140. If you divide those two, you get about 0.1718. And you want to divide here because your denominators are going to be different. Now let's look at the other one. The person is more likely to own a car if he or she lives in the city than if he or she lives outside the city. So it's still car ownership. But in this case, let's look at the outside the city. That denominator is 60, where 35 of those own a car. So 35 out of 60 is actually higher than 25 out of 140. So again, that's false. Letter D, the person is more likely to live in the downtown area in the city than elsewhere in the city. Now there's no conditional here, right? It just says the person is more likely to live in the downtown area than elsewhere. So let's look in the downtown area first. Downtown, we have 70 people. And out of what? Well, since there's no conditional, it's out of your total. So if you pick a random person, the probability that person's going to live in the downtown area is 70 out of 200. Now let's look at elsewhere in the city. Elsewhere in the city is going to be also 70 out of 200. It's the same numerator, so not one of those is more likely than the other. So that's not true. The person is not more likely to live downtown. In fact, that person is equally likely to live downtown than elsewhere in the city. And our last wrong one. The person is more likely to own a car than not own a car. So let's look at total car ownership. If you look at all the car ownerships, we have 60 versus 140. And we know that 60 is less than 140. Out of the 200 total people, 60 own a car, 140 do not. Therefore, that is not true. All right, that was probably the longest one. So the next video we'll go over number 4.